Okay, good morning, good afternoon, good evening, everyone. So I think it's the time to start this session. Um, Welcome to the software testing one session in the demo track of XC 2002. My name is Jifeng Shen from Wuhan University, China. I think most of you have already received the emails from the session chairs and from me. In our session, there are in total 4 papers and 4 demo track papers. Each of the presenter will have about 15 minutes, including 5 minutes about the live presentation and another 10 minutes for the demonstration and the question and answer. So basically we have 60 minutes in total. I think we can start the track. And also I see the session chair, Ms. Dan Hao, has joined our session. And it's very pleased to hold this session. Let's start our session. The first paper of our session is the G-Droid, an automated lightweight tool for replaying visual bug reports. Professor Chen, would you share your screen?
Yeah, sure. 1 second.
So basically, the 4 papers in our session are about testing, as the session title suggests. So this is the first presenter, Professor Chunyang Chen. So please.
Yeah. Hello everyone. My name is Sidong from Monash University. I will present our work, GiveDroid, an automated lightweight tool for replaying visual bug reports. First, I would like to briefly recap the motivation of our work. Bug reports are vital for software maintenance that allow users to inform developers of the problems encountered. However, writing a clear and concise bug report takes time, especially for non-developer or non-tester users who do not have that expertise and not willing to spend that much effort. A poorly written report will be even poorly interpreted. However, compared to instructions, video-based bug reports lower the bar for documenting the bug. First, it is easy to record a screen as there are many tools available. Second, video recording can include more detail and context, such as configurations and parameters. Despite the benefits of video-based bug report, it still requires developers to manually check each frame in the video and repeat it in their environment. We find that bug recording of a large number of frames and vary resolution make it difficult for developers to replay them in their setting. And also, as the important information to show users action, some recording contain touch indicator. However, we find that there are only a few recordings enabling the touch indicator, make developers have to guess and try the potential actions to trigger the target page. Therefore, we are motivated to develop approach to automatically replay the recordings for developers and testers. Our approach consists of 3 main phases: keyframe location, GUI mapping, and execution trace generation. That is said, given an import bug recording, we first localize a sequence of keyframes and subsequently map them to the existing GUI transition graph to extract the execution trace. Next, I'd like to briefly introduce each phrase. For the first phrase, the goal is to identify keyframes, set the states in which GUI are fully rendered. To achieve that, we leverage the image processing techniques to build a similarity score for consecutive frame comparison. And by observing the frame sequence, we annotate the keyframes from the recording if the GUI is in a steady state. That is, the consecutive frames are similar for a relatively long duration. Then, we map each located keyframe to the GUIs in the GUI transition graph. A GUI transition graph is usually used to illustrate the transition across different GUIs triggered by typical elements. To map the keyframe to the states in the graph, it is a well-known image searching task. We adopt feature extraction method to compute a similarity score and map the keyframes to the most similar GUIs. And after mapping all the keyframes, we obtain an index sequence in the graph. Finally, we utilize the index sequence to detect optimal replayable execution trace. However, we face two challenging problems. One is the previous approach for keyframe location and GUI mapping may not be 100% accurate. And the other one is the recording may start from any states in the application. To overcome the issues, we propose an algorithm to address the defective sequence in previous phrase and complement the missing states between application launch and the first keyframe in the recording. In detail, we first find all the sequence between application launch state to the last index state, and then select the sequence that has the longest common subsequence as the execution trace. In summary, the visual bug recording is training in bug reports due to its easy creation and rich information. To help developers automatically reproduce those bugs, we propose GIFDroid, an image processing approach to convert the recording to executable trace to trigger the bug in the Android app. And in the future, we will keep improving our approach for better performance. That's all for our papers. Thank you for your listening, and I'm happy to answer any questions.
Okay, thanks, Sidong. So anybody who has question, please open your mic and directly ask the question. And also you can use the chatting room to list your question there. Okay, so I will ask the first question. So as you have mentioned in your GIFDroid tool, and you can reproduce the bug reports, but what happens if some resource is unavailable? For example, if your bug report rely on something, for example, a database or some maybe networking connection. So what happens if this kind of thing happens?
I think it's a really good question. For right now, GIFDroid cannot solve this kind of complex problems. We can only replicate some simple bugs, which are not dependent on like dynamic content. But in the future, we hope to solve this kind of questions.
Okay, thanks a lot. So any other question? I think I cannot see my the message I sent from the chatting room. So I have sent some message, but I see nothing. So any other question? Oh, okay. So can I ask another question about the? So you mentioned it's a kind of recording and replaying. So that means all the content from the mobile phone can be recorded, or you directly select something. I mean, so you mean it's a kind of recording and replaying. So when you are recording the information, did you filter out something? Did you filter out any type of the data?
Not really. We focus on some general visual bug recording, like without any metadata or information at the background. So mainly we focus on the recording from the GitHub from the users, but sometimes user may not provide very useful information. They normally can just put a visual recording and say, "Oh, I find a bug and help me to solve this." So we focus on that kind of questions that do not have any metadata. Yeah, I hope that
Okay.
answers the question.
Thank you. So any other question? Okay, thank you, Sudong. So let's come to the next paper in our session. So Mr. Julin, so you can share your screen now.
Okay.
Okay, so the second paper of our demo track is test data augmentation of data point load by a metamorphic relation. So please.
Okay. Hello everyone. My name is Julin. I'm very glad to give you a short introduction to my demo paper, telling test data augmentation of LiDAR point cloud by metamorphic relation. With the rapid development of object detection in deep learning, application on LiDAR point clouds have received much attention, such as autonomous driving. To verify the robustness of objects detection models by testing, larger amounts of diversified annotated LiDAR points clouds are required to be used as test data. So we proposed a tool for LiDAR point cloud while testing data augmentation named Tolling. It is composed of three modules, namely point cloud configuration, coordinate filter, and object point cloud insertion. In point cloud configuration, Tolling divides the point cloud into non-road components and road components, and the feature of the object to be used for augmentation is calculated in this module. And in coordinate filter, this module randomly selects numerous candidate coordinates with the distance in descending order and insert objects with the size in descending order. The module will filter the appropriate coordinates for insertion based on several constraints, like the selected coordinates must be on the road. Objects inserted in the selected coordinates could not obstruct the labeled objects, and objects inserted in the selected coordinates could not construct the labeled object. For each candidate coordinate, we determine whether it meets the constraints by counting the number of points in area A, area B, and the 2D box. And in object insertion, this model is decided for the proposed metamorphic relation, the one-to-one correspondence between objects and their labels. Based on this metamorphic relation, Tolling inserts several different types of objects into the existing point cloud and updates the correspondence. Thus, the diversity of the test set increased in terms of the amount and the type of objects. To ensure that the augmented data conform to the physical characteristic of LiDAR. And Tolling deleted the point clouds objected by the insert object, the label for point cloud will be updated according to our metamorphic relation. It means when the object is inserted into the point cloud, the feature of the object must be inserted into the label of the point cloud. And in experiment, the first experiment is divided into 3 groups as shown this table. The result shows that as the augmented data in the test data increased, the APS of the modules decreased, indicating more bugs are being found. The MAP of the third group and the second group decreased in varying degrees compared with the first group, which shows that the model has insufficient generalization ability for the point clouds augmented by Tholen. So the test data augment by the metamorphic relation in Tholen could find the bugs in object detection models. And in second experiment, PV-RCN is employed to detect the objects in the test data and calculate the detection rates of the objects. The result is shown in this figure. Also, PV-RCN is a well-performant object detection model with high detection rate of the object in test data, with the increase of number of inserted objects, the detection rate of new objects and original objects declines. It is worth noting that even though the detection rates and numbers are inversely proportional on both types of objects in future, the data augmented by Tholen find more problems and with superior diversity. So Tholen could effectively augment test data for object detection models. And here is a usage of Tholen. Let's watch the video together.
And here is a usage of TAULIM. First, create a new augmentation task. TAULIM provides an efficiency way to configure and submit augmentation tasks. Based on the user's choice on the parameters of augmentation method, TAULIM reservices the params under testing and configurations on the number and types of objects, such as trunks, cars and cyclists. TAULIM provides the visualization of the point cloud before and after augmentation. Users can observe the effect of augmentation clearly.
That's all. Thank you for your listening and question.
Okay, thanks, Julian. Thanks for your wonderful presentation. Any question?
Hello, I have 2 questions for your presentation. And the first one is, what is the purpose of these constraints on the candidate coordinate selection? And question 2 is, how to use this a metamorphic relation to ensure that the data generated is valid?
Okay. Thank you for the question. They are good questions. For the first question, it relates to the connect of the second. Let me see this. It relates to the content of the second of the selected coordinate filter selection of the demo paper. To retain the semantic information in the sense of the input point cloud, Tolling filters candidate coordinates into selected coordinates following three constraints. The first constraint is that the selected coordinates must be on the road, since the objects in the non-road components have a limited impact on driving. The objects inserted in the augmentation are meaningful only when they are on the road components. And the second constraint is that objects inserted in the selected coordinate could not be constricted by other obstacles. If the inserted object is obstructed by other obstacles in the sense, the semantic information in the point cloud is not enough for deep learning models to detect the object, and leading to meaningless argumentation. And the last constraint is that objects inserted in the selected coordinates could not struct the labeled object. Labeled objects contains important information related to the label, so it is very significant to ensure that labeled objects are not obstructed. As for the second question, as we know, metamorphic testing is a property-based software testing technique, which can be an effective approach for addressing the test oracle problem and test case generation problem. By the way, the test oracle problem is the difficulty of determining the expected outcomes of selected test case, or determining whether the actual output agree with the expected outcomes. We can verify whether the actual outputs produced by the program under test from the source test case and the follow-up test case are consistent with the metamorphic relation in question. Any inconsistency indicates a failure of program caused by the fault in the implementation. Then when we apply this metamorphic relation to testing deep learning models for object detection, it has two uses. The first is for generating new point cloud data. What we do know is that there is a one-to-one correspondence between the labels in the point cloud data and the identifiable objects. The labels containing information such as the object's category, coordinates, dimensions, orientation, and so on. Point clouds generated by Thallium are often inserted with new identifiable objects. So the labels corresponding to generate point clouds also need to be accompanied by information about the insert objects, depending on the on the metamorphic relation. The second use is determine whether the model can still correctly identify the generated point cloud data. We compare the difference between the model output and the labels of the point cloud data to determine if the if the recognition rate of the model has decreased. If the recognition rate grows, then the model is fraud in some way. Thank you for your asking.
Okay, thanks, Jilin. Any other question? I have a fast question. So when you conducting the metamorphic relationship, is it possible to involve any false positive? I mean, is it possible to add some errors during when you conducting the metamorphic relationship? Jilin, can you hear me?
Hello.
Can you hear me?
Yeah.
Yes.
Can you hear me?
Yeah. Okay, Jilin, I have a faster question for you. So just now you have mentioned you can start the you can conduct the metamorphic relationship. My question is it possible to involve any error during when you conducting the metamorphic relationship?
I'm sorry, just.
Oh, okay, it doesn't matter. Okay, let's talk offline. It's okay. Okay, so thanks, Jilin. Let's move to the third presentation for today. Mr. Van Ran, are you ready for the sharing? Jilin, you can close your screen sharing. You can end your screen sharing.
Oh, okay.
The third presenter. The presenter of the third paper. Are you there? Anybody, can you hear me?
Yes, I can hear you.
Oh, okay. So, the presenter of the third paper, Mr. Van Ran, are you there? Okay. I think there is something wrong with the internet connection. So let's move to the fourth presentation today, and then we can wait for the preparation for the third presenter. So, Tianqi, okay, could you please share your screen?
Okay, wait for a moment.
Okay, so in our session, in our session we have four papers today, and the first one was about the visualization of bug reports, and the second one is about the 3D point cloud and the multimorphic relation, and the fourth one, the current presentation, is about the multidimensional evaluation of testing ability. So, Mr. Tianqi Zhou, please.
Hello everyone, I'm the presenter Tianqi Zhou, and I will do my presentation about multidimensional evaluation of testing ability. My presentation will divide into 4 parts. The first part is background, the second part is workflow, and the third part is approach, and the last part is experiment. Here is the first part, background. Software testing is an activity for evaluating the quality of software under test. About 30% to 50% of the efforts of a project are consumed by testing. As a result, testing assures the quality. So, excellent testers are in great demand in the industry. The software testing course is the way. The software testing course is a subject that is dominated by theory and focuses on operation and application. It has become imperative to organize online examinations through online testing platforms to evaluate students. However, relying only on code coverage cannot evaluate the ability of students. So we propose a meta, which is a more comprehensive multidimensional testability evaluation framework. We divide the testability into 7 dimensions, including the coverage recall, coverage precision, back detection, run efficiency, coding efficiency, and the maintainability and compatibility. And the meta supports these 3 testing scenarios, including developer unit testing, mobile application testing, and the web application testing. The next part is the workflow. Here is the workflow of Meta. The workflow Meta is divided into 4 modules. We design the test code analysis module to perform analysis tasks, such as the efficiency and coding style analysis. We design the task management module to manage evaluation tasks, including the creation and trying of the task and the query of the status of the evaluation tasks. The testability evaluation module is designed for establishing a testability evaluation indicator system using the 7 dimensions mentioned above, and the last module, visualization module, is designed to display the evaluation results. Then the next part is approach, and here we explain the 7 dimensions in detail. The first dimension is coverage recall. The coverage recall describes the extent to which the source code is tested. In the developer unit testing, this metric is calculated by this formula, where incov represents the number of the codes nodes that are covered, and meta represents the source code node number. And in the web application testing, with W represents the weight, and ACK represents the activity, and alpha is the parameter to control the formula, which is between 0 and 1. Then the second dimension, coverage precision. The coverage precision evaluates the precision of the actual coverage elements of the test code and verifies the degree of redundancy of the test code. For example, in the developer unit testing, unlike the coverage recall, the denominator is the incov. Then the third dimension, the back detection rate, evaluates the ability of the script to detect defects through present defects. In the developer unit testing, this metric is calculated by this formula, where MUK represents the number of the mutants killed, and MUT represents the total number of the mutants. The fourth and the fifth dimensions are about efficiency. And the running efficiency evaluates the difference in the running time of test code that achieves the same test effect, and the coding efficiency measures the amount of time students spend writing test code. We can see that in both of the formula, the numerator is the coverage recall, and the denominator is the time. The last 2 dimensions is maintainability and compatibility. Maintainability evaluates the coding style of the test code, which is evaluated by the coding style with JSTAR, a style checking tool. And compatibility evaluates the success rate of the test code in different hardware and software environments. In web application testing, this metric is calculated by this formula, where R success represents the number of the test codes that run successful, and RT is the total number of the test codes that run. And the last part is the experiment. Here is the system test environment. All parts of the system are deployed on Alibaba Cloud servers in the form of Docker containers. For the validity of Meta, 14 exams are selected from mock tests for experiment, involving 718 students participating in the exam. Table 2 shows the evaluation results of an example of developer unit testing type, and Figure 2 is the evaluation radar charts results between different students. From a detailed comparison of the 2 students, we can see that the ability distribution of the 2 students is obviously different, which means that from a more comprehensive perspective, the 2 students have different testing abilities. So in general, we can see that Meta can effectively reflect the performance all the dimensions regarding testing abilities. That's all for my presentation. And then now I have a video about the Tor demonstration. Let's see the video.
Teachers can get feedback on task progress while waiting for analysis results. In addition to multidimensional analysis results, Meta provides the assessment report. Coverage recall is equivalent to traditional code coverage. The detail list shows the coverage of different nodes. Coverage precision examines the accuracy of the actual coverage elements of the test code and verifies the redundancy of the test code. Bug detection checks the ability of the script to detect defects through preset defects and achieves the effect through mutation analysis. Users can view details of bugs that have been killed or survived. Running efficiency evaluates the difference in the running time of test code that achieves the same test. Coding efficiency examines the difference in coding time to achieve the same test effect. This dimension can reflect students' proficiency in test framework and grammar mastery. Maintainability examines the coding style. Detail list shows the information where the code violates the encoding rules. According to the historical evaluation results of each student's software test, Meta also provides statistics on the change of testability. The superimposed multidimensional graph of multiple testing tasks reflects the student's overall testing ability. For the convenience of users, a comprehensive dimension information introduction is provided on the platform.
And that's all for the presentation and the demo. And if anyone have the questions.
Okay, thanks, Tianqi. Any question?
Hi, Tianqi. I have some questions.
Okay, please.
How do the 7 dimensions come about, and in general, what techniques are used to implement the tool? Thank you.
Okay, and thank you for your questions. And let's go to the dimension. And for the first question, we have studied a lot of literature on test metrics, and many authors, have proposed metrics for test evaluation, but mostly coverage-related metrics. But in fact, this is obviously not enough, because a lot of times code with the same coverage is different in a lot of other features. Maybe, for example, coding style or compatibility and so on. At the same time, students differ in their proficiency in writing the same code. These objective conditions lead us to explore a more comprehensive assessment of the full range of testability. And concerning the calculation standard of different indicators for evaluating the software testing, mutation testing provides a testing criterion called mutation score, which is divided by the total number of the mutants according to the number of the killed mutants. And see, here is the 7 dimensions. In general, these 7 dimensions are considered comprehensively from the aspects of the test code, the coverage recall, coverage precision, and the mutation, the bug detection, and the efficiency, including the running efficiency and the coding efficiency, and the maintainability and compatibility. Each of these dimensions is an assessment of one aspect of the testability. And that's all for the first question. And for the second question, we can see the system test environment. And here is the system test environment. Table 1 shows the configuration of the system test environment. The front-end and the server-side projects of the testability evaluation service and online test teaching platform are deployed on Alibaba Cloud servers in the form of Docker containers. The reverse proxy provided by Nginx is used for front-end and back-end interaction between the front-end web platform and the server. And for the database, the system uses MySQL database to store student code submission results and or maybe related information and test code analysis results. And the MongoDB is used to store data such as analysis tasks, evaluation tasks, and the evaluation results. And the Redis is used as the cache service to store analysis tasks. And all tasks are submitted using Celery. Celery is a distributed asynchronous queue, and the tasks are distributed and executed through a message queue and the database. The benefit of using Celery is that the throughput and the availability of the system is greatly improved by using it in a asynchronous method. And about the visualization module, let's see. Last module, visualization module, we direct the front end based on the Vue framework combined with the eChart visualization module, and each page corresponds to a .view file, which is mapped to the router by definition the router components. And just we how see the demo video. And but due to the limited time, some technical details cannot be explained in detail. So if you have any other technical questions, you can send me email later. And that's all for the 2 questions. And thank you again for your asking.
Okay, thanks, Tianqi. Any other question? Okay, thanks, Tianqi, again. So you can end your sharing. So let's move to the final presentation of today. So Mr. Wang Ren.
Can you hear me?
Yeah, you can. Yeah, yes, I can hear you. So just now
Okay,
you
good,
have
good.
lost the line. So okay, you
Yeah.
can share your screen now.
Sorry. Wait a second. Yeah.
Okay, so the final presentation today is revisiting graph neural networks for vulnerability detection. This paper will be presented by Mr. Wang Ren. Okay, you can start. Oh.
I guess he disappeared again.
Yeah. Harris, do you have the backup video for him?
I can't see any video that's been uploaded, so I can play. Yeah.
Oh. Harris, can you see any backup video for him?
I can't see any video here. I can't see any option of the video.
Mr. Wang has come back.
Can you hear me? I'm sorry for my problem.
Yeah. Yeah. You can share your screen.
Yeah, I can see it.
Okay. Okay.
You
can start now.
Yeah. Okay. Thank you so much. I'm so sorry for my problem. So Today I would like to introduce our demo paper, the visiting graph neural network for vulnerability detection. So, you know, vulnerability detection problem have been grown recently, and the vulnerability are the main reason for cybersecurity attack. So that vulnerability detection is an essential yet challenging step to identify the vulnerability in the source code to provide security solution for software system. Therefore, in our demo paper, our goal is to develop a general, practical, and programming language independent model capable of running on various source codes and library without difficulty. Therefore, we consider the source code and library at a fast sequence of token to construct a graph, and then we apply graph neural network, and using some kind of a mixture between the sampling and graph pooling to get the graph embedding for the to represent the source code and to perform the classification. So for the first step, so we can see here, so we have a two graph construction approach. We follow for this one. We represent unique tokens at a node and the co-occurrence between tokens at a edges, and then we can obtain the graph heads, and you can see in this slide. And for second approach, when given a flash sequence of L tokens, we represent all the tokens in the source code at a node and cheating index. And cheating index at a node to represent the token, and the number of nodes equal to the number equal to the sequence length. We also consider the co-occurrence between the indexes at the axis, and so you can see the graph we construct for the source code, as you can see here. So after that, after building the graph, we use some kind of graph neural network with using the residual collection between the layer, and then using the sampling combined with map pooling to get the graph embedding, and followed by the softmax layer to predict the neighbor for the graph. For the experiment results, we examine our approach with gated graph neural network and graph convolutional network. For the graph construction, and we use two approaches: index focused graph construction and unique token focused graph construction. Also, for the node initialization, we use the embedding layer of two pre-trained programming language model such as CodeBird and GraphCodeBird. So as you can see here in the slide, so our approach got our approach outperform other approach and got the new highest accuracy result on this benchmark dataset. And here, so we also investigate the differences between using the different kind of combine the sampling and map pooling. So you can see we can use the sum between the sampling and the map pooling, the multiplication between the sampling and the map pooling, or concatenation between them. So in general, the mute here obtain the best result for our approach. We also examine the model behavior when we not using the residual collection and using the residual collection between the hidden GNN layer. And you can see in general, our approach with a residual collection obtains the best result. Yeah, thank you for the attention. And here in our we also provide our code in so you can check out our code. We provide our code at GitHub, and you can see the link in our paper. So in our code, we also provide the code here, so you can see the model we provide. So the model we provide here, so you can easily implement other kind of graph neural network if you want to improve the performance of the model. And yeah, that's all from my presentation. Yeah, thank you so much. Yeah.
Okay, thanks for the wonderful presentation. So I think this presentation is not easy, so it lasts for several problems. So any question about that?
Yeah.
Any question about this presentation? Okay, I will raise one question first. So just now you mentioned you are revisiting the graph neural networks, and this is used for the vulnerability detection. So my question is the revisiting is a kind of general general method, or it's general for general method for all the neural networks, or it's just a specific for the graph base, or can we extend it to the other kind of neural networks?
So in our case, because we aim to use the graph neural network, as you know, because at the moment graph neural network provide, faster and practical training and obtain the higher accuracy for other tasks like text classification or something like this. So that's why we aim to use graph neural network in our cases. And the thing is that also because we consider the so-called flat sequence of tokens, so that in our case our approach can run on many kind of can run on different programming language like C++ or Java or something like this. It programming independent language model. So yeah, so there are many kind of graph neural network you can use, but in our paper we examine gated graph neural network and GCN because there are two common two common kind of graph neural networks that people commonly use at the moment. So that we use this in our model. Yeah. So yeah, we can use other kind, something like graph attention network or advanced graph neural network, but in our paper we just use GCN and gated graph neural network. Yeah.
Okay, thanks a lot. So any other question for the Mr. Ren? Any other question? Okay, so I think all the 4 presenters have ended the presentation. So I also see several participants in the session. Do you have any question for the 4 presenters? Do you have any question for 4 presenters? Yeah, okay. So I think the time is we have 7 minutes left, and thanks for all the presenters, and thanks for all the participants, and also thanks for our volunteer Harris. Thanks a lot. So I think it's the end of this session. You can also join the other demo rooms, and also you can join the other sessions. Thanks you everyone. Bye bye.
Yeah, thank you.
Yeah, thank you everyone.
Thank you.
Have a good one.
Thank you.
Bye bye.
Bye.
Bye bye.